actually what we have used this equation. What equation did we use? We introduced a new term called conditional probability, and then we said conditional probability is the ratio of joint probability and marginal probability. Now, this is actually called Bayes rule. So, Bayes rule, and let us so essentially what does Bayes rule talk about? Bayes rule has a more generic explanation. So, generally what happens in reality is we have some initial guesses about events. Initial guesses are our they are called prior probability, they are called prior probabilities. So, using our usual concept of probability, we can translate these initial guesses into what are called prior probability. Those are our initial beliefs about some things. Those initial beliefs are there, let us keep them aside. What do we do next? We go and get more information. This information may be in terms of samples, maybe field test. In general, we get more information about these events about which we had some initial guesses. Now, because in light of this data collection, in light of the sample that we have collected, in light of the field test that we have conducted, what we may want to do is we may want to update our initial guess, we may want to update our initial belief about the events. The updated belief is called the posterior probability. Okay. The posterior probability is the new probability that we calculate for the same event, but this posterior probability considers all these things that we have done, right. We may have collected data, we may have collected a sample, we may have done some field test. In general, we have some additional information. Okay. So, what we have essentially done is there was a prior probability which may be because of our initial belief, which is our initial belief, and then we update our prior belief and calculate revised probabilities. Those revised probabilities are called posterior probabilities. So, what does Bayes rule do then? Bayes rule is essentially used to calculate posterior probability if we have some initial belief, if we have some initial probability and we have some additional sample information, right. Let us recall the example. That previous example was about B school admissions and two types of genders, male and female, being considered. Now, without any data, you may say that probability of admission to a particular B school may have some probability, right. Let us say that probability is 20%, 25%. Now, we collect data, right, and we may have data, and then we say that given that the candidate is a male candidate, what is the probability that he gets admitted? Now, we are talking about updated belief. We are still talking about probability of getting admitted. We are still talking about probability of getting admitted, but now we have additional information. We have information that this candidate that we are talking about is a male candidate. Now, we are saying how do you update the probability of getting admitted? We say that we have calculated posterior probability because we have additional sample information, and therefore, we use conditional probability to update our belief. Let us take an example of this, right. Let us take an example of this. So, let us say that there are two manufacturers. There is a manufacturer who has two suppliers, right, two different suppliers. Usually, this is very common in manufacturing industry. Usually, you do not want to rely on one supplier because if there is some disruption at one supplier's end, you should not get affected because of it. To mitigate that risk, to mitigate the supply risk, you want to spread and therefore, you want to use multiple suppliers. That is a very typical strategy commonly used in manufacturing industry. So, let us say that for a particular raw material, same raw material, right, both the suppliers essentially supply same raw material, okay. So, what has the manufacturer decided? Manufacturer has decided that 65% of the raw material, 65% of the requirement for the raw material will come from supplier 1, S1, and the remaining 35% of the raw material will come from supplier S2, okay, supplier S2. So, there is some arrangement, manufacturer has told supplier S1 to supply 65% of the manufacturer's requirement of the raw material, and manufacturer has told X2, supplier S2 to supply 35% of his requirement of the raw material. Okay. So, that is how the supply is happening. Now, you know that suppliers are not going to supply perfect quality products. So, let us say from historical data, you know that supplier S1 has 98% of the supplied raw material in good quality. So, there is a history that supplier S1 supplies good quality products 98% of the time, and supplier S2 provides raw material of good quality 95% of the time, or 95% of the raw material sent by supplier S2 are of good quality. Okay. This is also very common. Nobody is going to guarantee you 100% good quality raw material, right, because of process variations and various other factors. There may be some rejection, there may be some products which are not of acceptable quality, and this also happens very typically in manufacturing industry. I mean, you want to go, you want to get closer and closer to 100%, but you will realize that as you go closer to 100%, the cost actually goes up, and you may not be able to afford that cost, and therefore, you typically say that 95% is good enough acceptable quality for me, knowing fully well that 5% of the products I may have to throw away, or 5% of the raw material I may have to rework before I start using them. This is a scenario. Indirectly, if you understand, we have provided data, right? We have provided data 65% and 35%, 98% and 95%. If you compare this data to the contingency table of your B school admission example, you realize that instead of providing numbers, there we said that 324 candidates were offered admissions and so on. Here the data is being provided in percentages, right. That is the only difference. But just like that table, that data helped us build a contingency table, this kind of data is also going to help us build contingency table. This 65%, 35%, 98%, 95%, right. This should help us build our contingency table. But now, we are going to see how to calculate conditional probabilities without going to those contingency tables. I actually recommend that contingency table makes the job little easier. So, I am going to ask you to build the contingency table using this data that is currently on the slide. Build your contingency table. It will help you understand the data better. But we are going to look at the problem directly, right. So, if this data is okay, let me provide the scenario. What is the scenario? Okay. So, this is the scenario. So, this is essentially what we have provided. What does this 98% and 95% mean? This 98% and 95% are essentially conditional probability. Given the fact that the supplier is S1, given the fact that the supplier is S1, what is the probability that the raw material is of good quality? That is 0.98, right. This is what this statement means. Given the fact that the supplier is S1, what is the probability that the raw material is of good quality? That is 98%, which is the conditional probability. Similarly, this 95% you will realize is also conditional probability. This is the conditional probability that the raw material will be of good quality given the fact that it has come from supplier S2. What is the probability that the raw material being good quality given the fact that it has come from S2? That probability is 0.95. So, these are conditional probabilities. As I said, these are the numbers which can help you build your contingency table. Okay. Now, how will you calculate the joint probability? If I ask you this question, what is the probability that raw material is being supplied by S1 and it is of good quality? The moment you say and, it is a joint probability. So, go back, you know marginal, you know conditional probability, you know conditional probability, this is conditional probability. Now, from here, from this data, from the data on this slide, you want to calculate this joint probability, this joint probability, right, this is joint probability. So, this can be calculated using the Bayes formula that we have discussed earlier. So, what did Bayes formula say? Bayes formula said conditional probability is equal to joint probability divided by marginal probability. Now, we are interested in calculating the joint probability. So, how will you calculate the joint probability? Joint probability will be conditional probability multiplied by marginal probability, right. So, go back, what was this conditional probability of? This was a conditional probability of raw material being of good quality given the supplier being S1. So, let us write down in notation, right. So, what is this? This is probability that the raw material is of good quality given the fact that it came from S1. What will this be equal to? This will be equal to the probability that the raw material is of good quality and it is supplied by S1 multiplied by the marginal probability that the supplier is S1. Okay. So, how will you calculate this? How will you calculate this joint probability? How will you calculate this joint probability? This joint probability is going to be calculated as conditional probability multiplied by the marginal probability. How will you get this probability of S1 from this data? What is the probability of S1? What is the probability of, what is the probability that the raw material actually came from S1? Well, think about it, it is coming in the next slides, right. This is 0.65. Why is it 0.65? 0.65 because 65% of the raw material anyway comes from supplier S1. So, what is the general probability that the randomly selected raw material came from S1? It is 65%, okay, 65%, and therefore, the conditional the joint probability that the supplier is S1 and the raw material is of good quality, it should be and, or some textbooks use it a comma, does not matter which notation you use, that probability is 0.637. So, once again, what is this? How do you interpret this 0.637? 0.637 is the probability that the raw material being supplied by S1 and it is of good quality, that is this joint probability. Okay. Similarly, let us erase this so that we can read this carefully. Similarly, you can calculate the joint probability that the raw material actually came from S2 and it is of good quality, right. This is the joint probability and you figure out that that joint probability is 0.3325. Okay. Now, let us present a new scenario. Now, let us say that this manufacturer has inspected incoming raw material is coming in the trucks getting unloaded, right, and as soon as the material gets unloaded there is a incoming quality check, and in the incoming quality check the raw material is inspected and it is found to be of bad quality, okay, it is found to be of bad quality. Now, the question is, without looking at the papers, the manufacturer can look at the papers that came in the truck saying that this is the invoice and this is the challan and this is so on, telling you who is the supplier. Without looking at those details, simply by looking at the fact that the raw material received is of bad quality, can the manufacturer infer that it must have come from supplier S1 or it must have come from supplier S2? Once again, I will pose the question again. The scenario is, the manufacturer has just received a truck of raw material, the truck was unloaded, the raw material was inspected on receipt, the incoming inspection it is called, and that incoming inspection found out that the raw material which was supplied was of bad quality, Now, without looking at anything further, without looking at the papers and determining or asking anybody, the manufacturer wants to know who the supplier must have been, whom to blame. Okay. So, what is manufacturer interested in finding? The manufacturer is interested in finding the probability that the supplier was S1, or what is the probability that the supplier was S2, but the manufacturer is not interested in calculating the marginal probability, that the manufacturer already knows. 65% of the time raw material comes from S1, 35% of the time raw material actually comes from S2. So, you can't simply say that in this scenario also I received bad quality material, in this scenario also 65% of the time I will blame supplier S1, 35% of the time I will blame S2. That is not correct, because you are using marginal probabilities. You should not be using marginal probabilities, because you have updated information, you have collected data. What is the data? The data is the incoming inspection that you have conducted. The incoming raw material inspection is the additional data that you have with you. Okay. And you have found out that it is of bad quality, Okay. So, in light of this information, now can the manufacturer find out what is the probability that this raw material was supplied by supplier S1 or this raw material was supplied by supplier S2. Okay. Can we find that out? So, essentially we are asking ourselves a conditional probability question. Okay. So, essentially the manufacturer would like to know that I have a bad quality product in my hand, which was revealed during the incoming quality inspection. Which supplier needs to be blamed? Which supplier can be complained about? And we cannot simply say 65% of the time blames S1, 35% of the time blame S2. That I am already telling you, that is not the correct answer. That because that is the marginal probability, and as we have explained, we are not interested in marginal probability. We have additional information. We have information that that was known to us only after the incoming quality inspection. We have additional information. Why don't we use that additional information and then decide who the supplier must have been or may have been? Okay, that is the question that we are answering. So, essentially what we are interested in is, what is the we are interested in the posterior probability, right? Posterior probability that the supplier is guilty of supplying bad quality product, right? A particular supplier, given the fact that you already have a bad quality product at your doorstep. So, given the fact that you already have a bad quality product, what is the probability that it came from S1? Or given the fact that you already have a bad quality product in your hand, what is the probability that it came from S2? Okay. So, this is essentially Bayes rule. So, as we said, Bayes rule is conditional probability, ratio of joint probability and marginal probability. Now, we are going to play a trick. This joint probability can now be written as marginal probability and conditional probability again. This joint probability can be written as marginal probability and joint probability. So, writing that once again, this S1 and B can be written as probability of S1 and probability of B given S1. Why is that true? That is true because of what we had written earlier, right? Why is that true? We would have said, what is the probability that given the fact that supplier is S1, what is the probability that you will get a bad quality product? That is calculated as the joint probability S1 and B divided by the probability of S1. Now, if you say this is the joint probability, you multiply this and this is what you get. All right. Okay, I hope this is okay. Now you can similarly expand the denominator also. You can supply you can actually expand the denominator also. Now let us understand what is this denominator. What is the denominator? Denominator is the marginal probability that the raw material is of bad quality. It is the marginal probability that it is the bad quality product. Now there are only two sources for this. Either the bad quality product could have come from S1 or it could have come from S2. So what you need to do is, you have a bad quality product in your hand. So what do you need to do? You need to calculate the probability that you have bad quality given the fact that it must have come from S1, right, or you have a bad quality product given the fact that it must have come from S2. But what is the probability that the supplier was S1? That is the probability of S1. What is the probability that the supplier was S2? That is S2. Therefore, what is the probability that you will have a bad quality product in your hand? You will have a bad quality product in your hand if it was supplied by S1 or if it was supplied by S2. The moment you say or, you put a plus. The bad quality product must have come from either S1 or S2. The moment you say or, it is plus. Okay. So bad quality product could have come from S1. So that is the probability of bad quality product given the fact that the supplier was S1, or you have a bad quality product given the fact that it must have come from S2. So that is the marginal conditional probability. But what is the probability that the supplier was S1? That is probability of S1 or probability of S2. So that is how you expand the denominator also, right. So which is what is explained here. What is probability of event B? Probability of event B is the probability of receiving a bad quality product. Now the bad quality product could have come from supplier S1 or S2, right. So bad quality product is either joint probability of S1 and B or S2 and B. Now you can write S1 and B as multiplication of marginal probability multiplied by the conditional probability, and therefore you can expand the denominator as we had written in the previous slide. Now this is what you are interested in calculating, no? Essentially this is what you wanted. What is the probability that supplier S1 will have to be blamed given the fact that I have a bad quality product at my doorstep? This is what you were interested in. Now we have an equation for that. Now let us plug in the values and calculate the value of the conditional probability that we need. How do you plug in values? What is the probability of S1? You know the marginal probability of S1, which is 0.65. This is 0.65. This is 0.35. Marginal probability that the supplier is S2, right. 35% of the time the raw material is supplied by S2. Therefore, the marginal probability that the randomly selected raw material was supplied by S2 is 0.35, 35%. How do we get this? How do we get this? How do we get the conditional probability of supplier being S2, right? Conditional probability that the raw material is of bad quality given the fact that supplier was S2. For that, we go back to the first information about this problem. Okay, this we know this. We know this. Now what is this? This is a conditional probability that the raw material is of good quality given the fact that it was supplied by S1, that is 0.98. Now supplier S1 can provide or can supply either good quality product or bad quality product, right. You already know the conditional probability of good quality product. From here, can we not calculate the conditional probability of bad quality product? We should be able to know, fairly straightforward, 100 minus. Let us do that, right. So what is the probability that the raw material is of bad quality when the supplier was S1? 100 minus 98, which is 0.02, right. Similarly, what is the probability that the raw material was of bad quality given the fact that supplier was S2? Now, supplier S2 supplies good quality product 95% of the time, therefore, she must be supplying bad quality product 5% of the time, which is this 0.05, okay, which is this 0.05. And therefore, after this calculations, we find that the probability of supplier S1 being the culprit, given the fact that I have received a bad quality product in my factory, that probability is 42%, 42.6. Similarly, supplier S2 being a culprit, given the fact that I have a bad quality raw material in my hand, that probability is 0.574 or 57.4%. Now, let us look at the priors. What was the prior on this? What was the prior probability for S1? This was 0.65. What was the prior on S2? This was 0.35. Now, in absence of anything, you say that 65% of the raw material is supplied by S1. Therefore, what is the probability that the randomly selected raw material is supplied by S1? 65%. What is the probability that a randomly selected raw material is supplied by S2? 35%, 30.35. But you have additional information now. You inspected the incoming raw material and you found that the incoming raw material was of bad quality. In light of this information now, what is the probability that the culprit supplier was S1? You are calculating a posterior probability that the raw material was supplied by S1, given that the fact that the raw material was of bad quality. You are calculating posterior probabilities using your initial belief and additional data, additional quality data, inspection data, right. Now, you realize that probability is only 42%, even though 65% of the raw material is supplied by supplier S1. If you find a bad quality raw material, the probability that it came from S1 is only 42%. On the other hand, the prior belief about supplier being S2 is 35%, prior belief about supplier being S2 is 35%. However, if you find a bad quality raw material already in your hand, the probability that it actually came from S2 goes up to 57%. So, that is the difference between using prior knowledge or coming up with posterior probabilities with some additional information. This is the additional information. This B comes from the additional incoming inspection that you have conducted. You have additional data now. In light of this data, your probabilities change and those probabilities are called posterior probabilities of S1 and S2. So, that is the use of conditional probability, okay, once again being used in this case for supplier quality data. Okay. Once again, which are the two categorical variables in this example? The two categorical variables are supplier. Supplier is a categorical variable because there are only two, one is called S1, the other one is called S2. Now, do not think that this is S1 and therefore this will come first and this is S2, therefore this will come next. It can be arranged in any way. So, these are the supplier is a categorical variable which has two values S1 and S2. Quality is another random variable which has bad quality and good quality. So, this quality as a random variable, categorical variable has two values, bad and good. So, these are the two categorical variables and we have determined the association between the two categorical variables using Bayes rule, Okay. I hope this is understood. if you have not understood, we will definitely have tutorial sessions. You can definitely review the earlier discussion on conditional probability in other courses, or you can review this video again, and we always have help for clearing the doubts.